Hello everyone, my name is Nur Adila. So today I will talk about heat fact sheet. So my part is introduction. Let's go. Heat is closely related to our everyday life and one of the important aspects to keep our life going well. Heat is required in our daily life for a number of purposes, but one of them which is closely related to us is cooking. By using heat to cook our food, it can destroy potentially harmful bacteria and microorganisms so that the food is safe for us to eat and digest easily. Hence, what is heat and why is it important in our life? Heat is a form of energy that transfers from a higher temperature object to lower temperature object. It is transferred through conduction, convection, and radiation. In other words, heat is a thermal energy that will flow from a warmer areas to the cooler areas.
Hello everyone, I'm SYAHIDA and I will continue the misconception of heat. Misconception can arise from a variety of causes. A scientific misconception is often known as a preconceived thought or a conceptual misunderstanding. These are instances in which something a person knows or believes does not correspond to scientifically accurate. Students bring misconceptions into the class while learning science, which might inhibit the development of new concepts. When students have misconceptions at any level, the teacher plays a vital role in correcting the misperception. Meanwhile, the students will feel unfamiliar with their new information if teachers do not play a role because they cannot accept a new knowledge to the current level. Misconceptions regarding heat have been connected to the way teachers and textbooks depicted the knowledge and the use of incorrect language. Furthermore, students frequently have misconceptions demonstrated in the textbook illustrations. Many students were misconceived of heat where heat is a substance and not energy. They think of heat as the passage of energy from a heated item to a colder object. The fact, science defines heat as the transfer of energy from a warm object to a colder object. In the Physics KSSM Form 4 textbook, students might have a misconceptions when they observe the diagram of the flow energy and thermal equilibrium. Based on the diagram, a warm object P is shown as red, while the colder object Q is shown as blue. Students might develop their false understanding and conclude based on the diagram that the cold is transferred from one object to another, instead of thinking that actually heat is transferred from one object to another. The molecules in hot things move very quickly, and the temperature rises while the molecule in cold things move very slowly and the temperature smaller. Hot substance usually expand when heated. When a hot substance comes in contact with a cold substance, the heat energy will flow from hotter to colder until the objects become the same temperature. Insulators are materials that block the flow of heat, while conductors are materials that allow heat to flow easily. Sometimes students believe that insulators are heat sources because they make things warm or hot. Insulators will stop the heat from flowing, so things that are warm tend to stay warm. Nevertheless, they are not a heat source. Good insulators include plastic, air, fabric that hold air, feathers, or similar material. Based on the diagram above, the previous sets of incorrect ideas or understandings the students had before learning the topic might support the misconception from the textbook. The incorrect idea might strongly support the students' misconception. Thank you.
Hello everyone, my name is FATEEHA. Now we are going to continue with the next page of our fact sheet, which is the product description. Okay, to resolve the misunderstanding of students' misconception regarding heat, we have successfully created a courseware for the students to understand better about the heat. As you can see here in the fact sheet, we name our product as HEAT Courseware. The materials used to build our product are Microsoft PowerPoint and SlideSgo. The materials used really help us a lot to build this courseware since we are currently in ODL at each other's houses. Hence, it is hard for us to create a physical product together with all of our group members. Okay, now let's see the total cost we spent to build this courseware. The total cost that we have calculated for our courseware is 146 ringgit. That include 48 ringgit for electricity and 98 ringgit for the internet. The objective of our courseware include to enhance students' understanding regarding heat energy, to clarify students' misconception regarding heat energy, to provide students and teachers with a valuable education aids for teaching and learning process, and lastly, to ensure that students get the benefit from our educational aid during the classroom session. Then, let us proceed to the usefulness of our product. This courseware is useful to both teachers and students because, firstly, educators will be able to easily explain about heat with the aids of videos, pictures, and quizzes prepared in our courseware. Next, students will obtain the idea of misconception through the video explanation. Students will be able to distinguish between heat and temperature. Students can also increase their understanding of heat through the example and quizzes. Other than that, students will be able to differentiate between specific heat capacity and specific latent heat. Students can understand the relationship between heat and gas laws. Lastly, students will be able to understand the 3 gas laws in physics, which are Charles' law, Boyle's law, and Gay-Lussac's law. Now, let's proceed with the ways to utilize our product. Firstly, you have to open the PowerPoint file named HEAT Courseware. Then, you could simply press the F5 button on your keyboard, or you could click the slideshow button in the status bar to start the courseware. Next, you need to follow all of the instructions shown in the courseware. And lastly, to exit the courseware, you just have to simply click the escape key on your keyboard. For the commercialization potential of our product, we believe that our courseware have a good potential to be sold online. For example, we can sell our courseware to e-learning marketplace such as to the Digital Class and Coursera that connects every students and teachers globally. Other than e-learning marketplace, we could possibly sell our product through online advertisement. Most students are attracted by different kind of attractive advertisement from various fields. We could broadcast our products on social media and receive the reviews from targeted people. Next, we could try to publish our product using mixed media books. We can collaborate with the textbook's author to convert the textbook into e-book courseware and put it into a compact disc called SCD. In order to protect the courseware contents, we will retain the copyrights of all contents on the CD that include pictures, videos, music, audios, and written materials. We also provide new ISBN for the e-book to secure the courseware value.
Hello and Assalamualaikum. My name is Noalia AZIERA, binti Mama ANIZA, and with me, you're going to venture our creative product for the misconception about heat. So without further ado, let's get started. By looking at the screen, you will see our cover page for the misconception about heat. We put the theme, the chapter, and also there is a start button for the student and teacher to click so that they can begin their journey with our courseware. So we can click on the start button. After we click at the start button, it will directly show student and teacher the home page for the courseware, which is there is a 5 bubble represent for a 5 subtopic. The first subtopic we will have thermal equilibrium. Second, we have specific heat capacity. The third bubble, we have specific latent heat. The fourth, we have gas law. And the last bubble, we have quiz. And then there is a X button so that the student can easily exit the page whenever they want. And the cartoon also will give instruction for the student and teacher to click on the topic that they're interested to learn with. So, for example, I click on the first subtopic, which is thermal equilibrium. So first, we're going to look at the first subtopic, which is the thermal equilibrium. By clicking at the next button, we will see the definition for the thermal equilibrium, and then student can choose whether to read or to listen to the thermal equilibrium definitions. And then there is a clip art, a moving clip art, so that student can easily understand the flow of the heat between two bodies there is in thermal contact. And then there is a graph and also explanation so that student and teacher can use during class session. And then there is definition for SI unit temperature, definition for freezing point and boiling point, and then the applications of the thermal equilibrium. In the application of the thermal equilibrium, it is actually an example so that student and teacher can further discuss during class. There is explanation that student can read without teacher explaining to them. Okay, moving on to the next subtopic, we have specific heat capacity. In the specific heat capacity page, we have the definition for heat and temperature. And then there is a fun fact that student and teacher can discuss during class. And then we have the definition for specific heat capacity. We also insert a lot of examples so that student and teacher can discuss during class. There is also explanation so that student can read. In the specific heat capacity, we also insert a video for further understanding about specific heat capacity. Student and teacher can watch the video by clicking at the button. And then we also insert table of the specific heat capacity that is usually used during class session. Next, on the specific heat capacity, we have the comparison between water and aluminium. This example will give student and teacher the example so that they can distinguish between two elements, which one require a lot more energy to raise 1 kilogram of the element by 1 Celsius. And next, we also put the formula and also the explanation for every terms used in the formula, so that student and teacher does not require textbook during their lesson session. Student and teacher can fully use our courseware during their class session. On the third subtopic, we have the specific latent heat. In specific latent heat, student and teacher will discover about solid, liquid, and gas. If the student and teacher click on the image shown on the screen, the first image of solid, it will show you the movement of solid, the movement of liquid, and also, last but not least, is the movement of gas. From the movement of the particles inside solid, liquid, and gas, student and teacher can easily refer so that they can differentiate between the movement of every matter, every state of matter shown on the screen. And then we have the definition for specific latent heat. After that, there is example of melting candle so that student and teacher can discuss during class. As you can see on the screen, this specific latent heat is particular to state change. there is ice to water and also water to steam. Student and teacher can click on the play so that they can see how ice turn into water. And for the water to steam, you can also click the play button so that you can see how water turn into steam. Next, student will discover about the three heating curve, which first we have the heating curve of the solid, and then there is a graph shown on the screen, and then there is also an object that with its particle movement, so student and teacher can easily understand how the heating curve looks like in real life. The next heating curve is for liquid. It shows you how the heating curve will be plotted if the liquid, and the next and last heating curve is for gas. Student and teacher can easily relate the heating curve with the image shown beside the graph. And next we have the definition for specific latent heat of fusion and also specific latent heat of vaporizations. These are the simplified terms used in our courseware. And then there is also formula in the specific latent heat equations. We also describe all the equation used in the specific latent heat of equation. We also explain the specific latent heat equation in our courseware. So for the fourth subtopic, we have gas law. In gas law, student and teacher so the first page for subtopic gas law, student and teacher will learn about the 4 behavior of gas in understanding the gas law. We have the first one, the volume occupied by a gas, and then second, the pressure exerted by a gas on the wall of its container. The third, the amount of gaseous substance or the number of mole of gas, and then the fourth behavior of gas is the absolute temperature of the gas. And then student and teacher will learn about the 3 gas law, which is Charles law, Boyle's law, and also Gay-Lussac law. So the first gas law is the Charles law. There is a formula stated on the screen that student and teacher can easily refer to during the lesson, and then there is a picture to make student more understanding about the topic, and then there is a relation between volume and temperature. On the next page, we have the Charles law explanation with the photo with moving particle. Student can easily understand the meaning of what happens if the particles are exposed to heat. And then there is a application of Charles law student and teacher can refer to so that they can discuss during class about the application of Charles law in their daily life. On the next page, we have Boyle's law. Same as the Charles law, in the courseware we will explain the Boyle's law equation, and also we provide the relationship between the terms that are related to Boyle's law, and there is also picture that student and teacher can easily understand during their lesson session. And the next page, we have the moving photo that will show you how the Boyle's law is explained in a photo. There is also explanation and also relationship between the pressure and also volume. And next we have the application of the Boyle's law. There is also an explanation for the application of boys' law, which is the uses of syringe. The next is gay-lussac law. Same as the child's law and boys' law, there is also explanation and also relationship in the equation shown. In the gay-lussac law, there is also moving photo that will explain how the temperature will affect the movement of the particle. And then there is application of the gay-lussac law and also its explanation of the application in our daily life. Okay, that is all for the subtopic of heat. In the courseware, we also prepare student and teachers some quizzes for them to answer during class to improve the student understanding about the heat and also correct them about their misconception about heat. Clicking at the start button, student will start doing their quizzes. There is a MCQ question which student will choose the multiple choice of answer, which one is correct. For example, we have question 1. There is a question and also a picture for student to understand the question better. So for the first, for the first question, if the student answer A, which is correct, all the other answer will be read, and that indicates that the answer is wrong. Meanwhile, the correct answer will give a green color. And also, after they answer the question, there are also explanation if you click at the explanation. The explanation for the question that the student answer. For the quizzes, we have a total of 10 questions. So student and teacher can do this exercise together during their class session. So we have reached the end page of our creative product, which is our courseware, the misconception about heat. I'm hoping that this courseware will give student and teacher benefit from the courseware so that they can use our courseware during their class session. To fully utilize our courseware, you can get our courseware from the website, and also you can contact us to get the courseware. I think that's all from me. Thank you.